This is a frictional force problem on an incline.
A 18.4 kilogram child is on a slide that is 37.4 degrees above the horizontal. What is the frictional force of the slide on the child if the child starts at rest? The slide is 2.34 meters long and it takes him 1.7 seconds to go down the slide.
Gemma and I took Gemma's little brother John to the park to demonstrate this exact problem.
Cute. First, we need to write out all the givens. So we know the mass is 18.14 kilograms. We know that the initial velocity equals 0 because he starts from rest. Theta is 37.4 degrees. The slide was 2.34 meters, so that's the distance. And the time it takes him to go down the slide is 1.7 seconds. And we know the force of gravity is 10 times the mass, so that is 181.4 newtons. And we're looking for the frictional force. So after we find the givens, we then have to draw a picture. So here's our picture, and we have to draw all the forces on John. Okay, so we have the frictional force, which is the force that we're trying to find. And then we have the normal force, which is pointing up this way. And then we also have the force of gravity pulling him downward. We know that, so here's our triangle, right here. This is a right triangle, and this is the angle we are given. So since we're at an angle, we have to, our x and y axes are different. So this is our x-axis, and this is our y-axis. So that means we have to get our x and y axis of the force of gravity down here. So we just make a triangle. Since we know that this is theta we know this angle because these two are corresponding angles. So this is g of y, and then this is g of x. And also, since all these forces cancel each other out, g of y has to be negative if the normal force is going to be positive. And that means that g of x is positive, so the frictional force, what we're finding, is going to be negative.
First, we need to find the acceleration of the x-axis. We only find the x-axis because John is not accelerating in the y-axis. We can use the formula d equals vit plus 1/2 at squared. And we solve for acceleration. So distance is 2.34, which equals 0. So since vi is 0, that changes the entire equation to that part to 0. So then we have 1/2 the acceleration times 1.7 squared. And oh, sorry. Okay, so then that means that the acceleration equals, hold on. Acceleration equals 1.62 meters per second squared.
We can use the fact that the acceleration of x is 1.2 meters per second squared, and the mass is 18.14 kilograms. The force of gravity is negative 181.4, and remember that one's negative, to solve for the frictional force. But before we can find what the frictional force is, we have to find what the force of gravity in the x direction.
We use the concept g of x equals a force of gravity times sine of theta, and we plug this into the equation and solve with the givens. We solve for force of gravity on the x-axis. So g of x equals negative 181.4 times sine of 37.4. And that gets us g of x equals 110.18 newtons. Finally, we use the equation sigma f of x, which equals m times a of x And this means that all of the sums of the forces in the x direction, we only use the forces in the x direction because he's not moving in the y direction, so it is irrelevant to this problem. As we said before, we are using the equation sigma f of x, which equals mass times the acceleration on the x-axis. This means that all of the sums of the forces in the x direction, so the equation ends up being the force of gravity in the x direction, which equals the mass times the acceleration in the x direction.
So g of x, or the force of gravity in the x direction, is 10.18 plus the frictional force equals the mass $118.14 times 1.62. So you end up getting the frictional force equaling negative 80.79 newtons. And then you're done!
Yay, done!
The end.